Hello everyone, in this video we will see the data types in Solidity, and now we can start with the same with the first data type, which is Boolean. A Boolean is created by specifying the bool keyword here, the first thing, and then this is the access modifier. It can be internal and private also, and this is the variable name, and this is the value. So a Boolean can be either true or false. It's similar to other languages. And now let's create the second data type, which is integer. Integers you will not need to use them a lot, but of course you need to know them. Integers are numbers that we know. They can be negative, they can be positive, or they can be zero. And integers, they have flavors, and these integers, by saying integer 8, the number of or maybe first I can explain you this, how you create an integer variable. So to create an integer variable, you just need to say int, an access modifier, and the name of the variable, and here is the value. But here if I say integer, for example, integer 2, integer 8, then it means that this variable will have a limit for the value that it can take. Okay, that's why they are this kind of integers, and why it's used, because it helps you to save gas. So when you say integer 256, it will by default will be equal to int, and this is the maximum value for an integer that can take. But you will not to use integers much. You will not to neither see them or nor to use them often. Now we can move on to the main number data type that we will be using. It's called unsigned integers, UINTs. And UINTs can only take positive numbers. They are also coming with flavors: UINT 8, UINT 16, UINT 2, UINT 24, UINT 256. So when we say UINT 8, it means this UINT 8 will have a limit for the number that it can take as a value. For example, UINT 256 means UINT 256 is by default is equal to UINT, and it's also equal to the UINT 2 to the power of 256. And 2 to the power of 256 is a huge number, which you see here. And minus 1. If it wasn't minus 1, it would be 6. Okay, so it is minus 1, it's 5. And I guess that's it for now. Maybe we can move on to the other example. The other data type, which is enums. Enums, they help you to create the contacts for your future variables if you would like to group them together for a certain purpose. In this case, imagine I would like to store the options of customers who are coming to my burger restaurant, who are like saying that I would like to have this burger, the other one is saying that burger. So I am like saving their choices as here I said my favorite, or you can think that as customer 1, customer 2, customer 3. And instead of like saying the numbers here, instead of creating this instead of creating this variable with a UINT, I can create an enum, and here I can specify what the variables can take as value. It can be big, medium, small, and on the background a big as big is the first element of this enum. You can think enum as a list. It will have the value of 0, and the medium will have the value of 1, and small will have the value of 2. It acts like a list, like an array. And here when I say burger.pick, it means that this variable is created with this enum, which is called burger, and it has this value, burger.pick. Burger.pick, what is it? It is 0. And now let's go to bytes. Bytes, probably they are hardest to understand. Bytes are a unit of measurement of computer memory, as you know. And sometimes, and at the contract level, you will see bytes like that. You will see that it's equal to a string or a hexadecimal value. So when it is equal to string, it shouldn't confuse you. For example, this string right now, we can read it, isn't it? It's Martin, it's my hometown city. You can read it. It's in the UTF-8 format, but later, when we deploy this contract, these bytes will, as we declare this variable with bytes format, it will convert this to bytes format, and bytes format is hexadecimal format. It starts with 0x, and then it's an alphanumerical value. Why it's doing that? Because sometimes at the contract interaction level, for example, for you that's fine, you are seeing that it's Martin, but another contract is not you. It doesn't have eyes as you have. So that other contract can read this value only if it is in bytes format. That's why we are using bytes format, and of course for some other purposes also, but that's one of the purposes that we use bytes. It's cheaper to use compared to strings. So that's it. No, here also the bytes, they come with flavors. It can be bytes 1 to bytes 32, and there is a limit for a bytes type variable. Okay, I mean this variable, it cannot go forever. The limit is 32 characters if you are going to use the characters that we know. So the limit is 32, which means that if I say here 2, it should give me an error, isn't it? Because 2 bytes 2 means it can only have 2 characters as value. So let's now save it, and you see it gave me an error. To overcome this error, I can say byte 6 because this character is 6. Now let's save it. Yeah, it works. And now here is the address. Addresses, they are also in hexadecimal format, which means that they are starting with 0x, as you can see here, and then they are having this alphanumerical value. And addresses, all the contacts that we deploy, and also the MetaMask accounts that we have, they have addresses. Okay, it's something specific to Ethereum ecosystem. And then we have strings. Strings are maybe easier to understand, and strings, they don't have a certain limit. You can create a string as much as you want. Unlike these bytes, it can go on and on, you know, it's up to you. And after that, we can go on arrays. Arrays are used to group same type of elements. So here I have created an array by saying this array. To use array, first I need to specify this array sign, and here is the type of the array. It's string array, and here is the values. Okay, and if I say, for example, UINT, it means that this array will be a UINT array. And that's it. And now let's go to structs. Structs are, so I will use the similar words that I said for the enums. Structs are given a context for our variables. Imagine that I would like to create many variables about cars. So instead of creating all of them independently, I can just create a struct, and for the future variables I will force them to follow this structure. And to force them to follow this structure, I will first start with the structure name. In this case it's cars, and then this is the variable name, and this is how you assign values to a struct variable. Okay, and after that we can also talk about mappings. Mappings are very useful. Instead of we think that we have 1000 words, so we may need a certain word to use. So instead of using an array to store all the words inside and then using a for loop, we can use this mapping, and it will be much easier to grab that word that we are using. And by using mappings, we will save lots of gas. That's why you will see mappings in all contracts, and you will also need to use them in your contracts. So that's all about the data types, and definitely you will need to, we will do some more exercises about them, but for now that's all about it. And maybe I can just show you some examples how it looks. Maybe I will show you this variable, struct variable here, which is named my car. Let's go up here, let's find it. You see my car, it says Chevrolet, it says 1000. It's how it looks. A struct variable looks like that. And more than that, maybe this mapping right now it's empty, but I can still, you know, do a test. My mapping, where is it? Here. So if I say 1, it should return me an empty string. Yes, it returned me an empty string. So that's how it is, and see you next time. Bye bye.